Alright, so today we're going to continue our conversation about adding linear expressions. This is our day 2 of this lesson, and again, we're just working with how to add linear expressions. But today we're going to bring in that distributive property. We're going to bring it back. So a little bit of review. We talked about a linear expression being an algebraic expression in which the variable is raised to the first power, meaning there is no power of x other than 1, or whatever the variable might be. There is no power of that variable other than 1. And in the last lesson, we learned how to add those expressions. Today we're going to continue, and we're going to jump right into examples, and we're going to notice that with our very first example, we don't just have x plus 3 plus 3x plus 1 as our linear expressions that are being added, but we have 2 times the quantity x plus 3. So this reminds me of the fact that I have to use the distributive property, and if you forgot how to use that, that was the section on the distributive property. There's a video, and this would be part 2 that you'd want to focus on, not part 1. So we know we need to use the distributive property. So I'm going to draw my arrows to help me. So I know that this is going to be 2 multiplied by my first term. I'm going to bring down that plus sign, plus 2 multiplied by my second term. And then, since I'm not distributing anything into these parentheses, I can leave that 3x plus 1 as 3x plus 1. Well, 2 times x is just 2x, and 2 times 3 is 6. So now I have an expression that looks like what I had been working with in the last assignment. So I'm going to regroup to bring my like terms together. I know that 2x and 3x are like terms, and I know that 6 and 1 are like constant terms. So when I regroup, I have 2x plus 3x plus 6 plus 1. Well, 2x and 3x is 5x, and then 6 and 1 is going to be 7, so my final answer is going to be 5x plus 7. Now, I didn't need to write this step out, but it is helpful if you want to just do one thing at a time. I could have gone straight from here to here. Okay, so final answer 5x plus 7. Since I have no more like terms, I can't combine. Let's try another one. So we're going to do 3 more examples, and they're all going to be very similar. So I take a look at this one right here, 4 times the quantity x plus 1 plus the quantity 5x plus 2. Again, I see that I'm going to need to use the distributive property. So that's going to be 4 times x plus 4 times 1. Again, you always bring down the sign. Plus, I can remove these parentheses now, so that's 5x plus 2. When I carry out my multiplication, I'm going to have 4x plus 4 plus 5x plus 2. Now it's time for me to look and see what my like terms are. I know that 4x and 5x are alike, and I know that 4 and 2 are like constant terms. So I'm going to rewrite this. 4x plus 5x plus 4 plus 2. Well, 4x and 5x, that makes 9x, and 4 plus 2, well, that's 6. Again, once I have no more like terms, I can't combine any longer, so that's going to just end at 9x plus 6. Can't combine anymore. Okay? So these are all going to be pretty simple. We're not going to be subtracting today. We aren't going to be subtracting our linear expressions, so to say, but we may have subtraction. But remember, we're going to turn all subtraction problems into addition problems. So we're going to start by distributing. This example is a little different because of those minus signs. I know that's going to be 5x, and remember we drop down that minus sign. 5 times 4 plus, in this case I'm not distributing anything into the 2x minus 7, so I'm just going to leave that as 2x minus 7. 5 multiplied by x is 5x. 5 multiplied by 4 is 20, plus 2x minus 7. And as we had done before, I'm going to turn this into an addition problem. So I know this is going to be 5x keep plus negative 20. Then this is a plus sign, so I can skip that, 2x plus negative 7. That allows me to look at it from the terms of an addition problem, which means I can add in any order I want by the commutative and the associative properties. So I'm going to rewrite this to group my like terms. I know that 5x and 2x are the same, and I know that are like terms, not the same. I know that negative 20 and negative 7 are like terms as well. So when I rewrite this problem, I'm going to have 5x plus 2x plus negative 20 plus negative 7. When I combine my like terms, 5x and 2x, that makes 7x, plus negative 20 plus negative 7, that's negative 27. Now I can leave my answer like this, that's fine. Or I could get rid of that plus minus, and I know that plus minus is just minus, so that's going to be 7x minus 27. Okay, one more example. At this time I think it would be really advisable to just pause the video and try this one ahead of me. And let's get into the answer. So again, I see that I have those minuses, but I'm not going to worry about them until I've used the distributive property. So I'm going to have 3 multiplied by x minus 3 multiplied by 8 plus, again, I can remove those parentheses, 4x minus 5. So this is going to be 3x minus 24 plus 4x minus 5. Before I go one step further, I'm going to turn this into an addition problem. Keep, change, change. So that's going to be 3x plus negative 24 and 4x plus negative 5. So when I regroup to bring my like terms together, I know that 3x and 4x are alike, and I know that negative 24 and negative 5 are alike. So my new statement is going to be 3x plus 4x plus negative 24 plus negative 5. I know that 3x and 4x are going to make 7x together. And I know that negative 24 and negative 5 are going to make negative 29 together. Again, I am okay to stop here and leave my answer as such. Or I could simplify it to 7x minus 29 for a final answer. Alright, so we're ready for the problem of the day. 2 problems, okay? They're both going to have that subtraction because that is going to be the tougher part of this lesson to get used to. So try your best. If you need to rewind and watch one of the examples again from the last 2 examples, that's totally fine. And we'll go over this tomorrow. Have a great night.